If the universe is so big, 13.8 billion years old with billions of stars, where are all the aliens? It's a question that's haunted scientists and philosophers for decades, and it's known as the Fermi Paradox. Named after physicist Enrico Fermi, who during a casual lunch conversation in 1950 famously asked, "Where is everybody?" Fermi wasn't suggesting aliens were at the next table, but he was pointing out the mind-boggling contradiction between the high probability of extraterrestrial life and the lack of evidence for it. Today we'll dive into the most mind-bending theories from top scientists to solve this cosmic mystery. Stay tuned. The Great Filter Hypothesis, proposed by Frank Drake and later expanded by Robin Hanson, tackles the Fermi Paradox with a sobering thought. What if there's a barrier, a cosmic hurdle, that prevents life from reaching advanced stages? This barrier, this great filter, could be behind us, meaning we've already cleared it. Or it could be ahead, looming like a cosmic brick wall. For life to flourish and evolve into a spacefaring civilization, countless steps must occur successfully. Life itself needs to emerge, then evolve from single-celled organisms to complex beings. Intelligence needs to develop, followed by the ability to create technology. That's a lot of hurdles to clear, and the Great Filter suggests that somewhere along the way, most, if not all, civilizations hit a wall. Robin Hanson, a professor of economics at George Mason University, has delved deep into the implications of the Great Filter. He argues that the filter might not be some rare astronomical event but something self-inflicted, a consequence of technological advancement itself. The filter might be a catastrophic event, like nuclear war or climate collapse, that wipes out civilizations just as they're on the verge of reaching for the stars. It's a chilling thought, isn't it? That our own ingenuity, our thirst for progress, might be the very thing that prevents us from encountering other intelligent life forms. But if the Great Filter is behind us, if we've already cleared this cosmic hurdle, it has profound implications for our place in the universe. It suggests that we might be one of the very few, the lucky ones, who made it through. Yet even if we are alone in having navigated the perils of the Great Filter, the question remains, what exactly was the filter, and can we help others avoid it? These are questions that continue to fuel scientific inquiry and spark our imaginations. The possibility of a great filter is a stark reminder of the fragility of life, even on a cosmic scale. But the Great Filter is just one theory among many. Let's explore other equally fascinating and unsettling possibilities. What if we're not alone, not by a long shot, but those who are out there are watching us from a safe distance? This is the essence of the zoo hypothesis, a concept that's as intriguing as it is unsettling. Imagine this. Earth is like a cosmic wildlife preserve, and we, dear viewers, are the unsuspecting exhibits. Our galactic neighbors, far more advanced and perhaps a bit wary, have decided to observe us from afar, much like we study animals in their natural habitat. Astrophysicist John Ball first proposed this idea back in 1973, suggesting that advanced extraterrestrial civilizations might be deliberately hiding from us, not out of malice but for our own good. They've established a galactic prime directive, a cosmic version of take only pictures, leave only footprints. In Ball's own words, they may be observing us, but they've set up a no interference rule. If a vastly superior alien species exists, capable of traversing the cosmos, they likely possess technology and knowledge beyond our wildest dreams. To them, we might seem like ants going about our daily lives, oblivious to the larger universe around us. The zoo hypothesis suggests that these advanced beings are engaged in a cosmic ethical debate. Should they reveal themselves to a species still grappling with its own existence? Or should they allow us to evolve naturally, free from their influence, even if it means we remain unaware of their presence? Some might find this idea unsettling, even a bit creepy. But is it really so far-fetched? After all, we humans have established nature reserves and wildlife sanctuaries to protect vulnerable species, often observing them from a distance to minimize our impact. The zoo hypothesis raises profound questions about our place in the universe and the ethical responsibilities of advanced civilizations. Chapter 3. The Rare Earth Hypothesis. Are we one of a kind? What if the conditions that gave rise to life on Earth are so incredibly unique, so mind-bogglingly improbable, that we're essentially a cosmic fluke? This is the crux of the Rare Earth Hypothesis, a perspective that's both humbling and, let's face it, a bit lonely. The Rare Earth Hypothesis, championed by geologist Peter Ward and astrophysicist Donald Brownlee in their 2000 book Rare Earth, argues that while microbial life might be common throughout the universe, complex intelligent life, life capable of building civilizations and pondering the cosmos, is exceedingly rare. For life as we know it to exist, a planet needs to reside within a star's habitable zone, where temperatures are just right for liquid water. It needs a stable orbit, a protective magnetic field, a moon to stabilize its tilt, and the right chemical cocktail for life to spark in the first place. That's a lot of boxes to tick, and according to the rare Earth hypothesis, Earth is like winning the cosmic lottery time and time again. As Peter Ward puts it, Earth might be a 1 in a trillion fluke. Proponents of the rare Earth hypothesis point to several factors that make Earth particularly special. Our Sun is a relatively stable star, unlike many others that are prone to violent outbursts. Our solar system is situated in a relatively calm region of the Milky Way galaxy, far from the galactic center, where supernovae and other cosmic events are more common. Even the presence of Jupiter, our gas giant neighbor, plays a crucial role. Its immense gravity acts as a cosmic vacuum cleaner, deflecting comets and asteroids that could pose a threat to Earth. Taken together, these factors suggest that the conditions that allowed life to flourish on Earth might be incredibly rare, perhaps even unique in the observable universe. If the rare Earth hypothesis holds true, it has profound implications for our understanding of life in the cosmos. Chapter 4. The Transcension Hypothesis. Have they moved on? What if advanced civilizations, those far beyond our technological prowess, aren't hanging out in our usual understanding of space? What if they've moved on, transcended to a different plane of existence, leaving us behind in their cosmic dust? This is the crux of the Transcension Hypothesis, a mind-bending idea that pushes the boundaries of our imagination and challenges our very definition of advanced. Futurist John Smart, a proponent of this theory, argues that as civilizations advance, they inevitably develop technologies that allow them to manipulate energy and matter at the most fundamental levels. Think nanotechnology, quantum computing, even manipulating the very fabric of space-time itself. With such power, these civilizations might reach a point where they choose to leave the limitations of our familiar universe behind, migrating to environments more suited to their advanced needs. Think of it as upgrading from your old desktop computer to a state-of-the-art virtual reality system. As John Smart eloquently puts it, they could be living in inner space, not outer space. Civilizations so advanced that they no longer need starships or wormholes to explore the cosmos. Instead, they've turned inward, creating their own pocket universes, perhaps within black holes or other exotic cosmic structures. These civilizations might exist outside of our current understanding of physics, operating in dimensions we can't even perceive. They might be composed of pure energy or information, their thoughts and actions occurring at speeds that make light seem sluggish in comparison. The Transcension Hypothesis suggests that the search for extraterrestrial intelligence might be a bit like looking for a digital signal using an AM radio. It's a humbling, even daunting thought, but it also opens up a realm of possibilities that are as exciting as they are mysterious. Chapter 5. The Self-Destruction Hypothesis. Have they destroyed themselves? What if the most advanced civilizations never get the chance to reach out to the cosmos because they self-destruct, victims of their own technological prowess? It's a chilling thought, one that's been explored by scientists and science fiction writers alike. This is the grim reality proposed by the self-destruction hypothesis. It suggests that intelligence, while a remarkable trait, might also be a self-limiting one. As civilizations advance, they develop powerful technologies. But those very technologies can become the tools of their own demise. We humans have already developed weapons capable of wiping out our entire species. Nuclear weapons, biological warfare, even artificial intelligence run amok. These are all potential threats that could bring about our own downfall. Carl Sagan, the renowned astronomer and science communicator, famously said, "Technological adolescence is the most dangerous phase." He was referring to the idea that as civilizations develop advanced technologies, they go through a period of vulnerability, a time when their capacity for destruction outpaces their wisdom in using it. Imagine a civilization on the cusp of achieving interstellar travel, only to be torn apart by internal conflict fueled by their own technological advancements. Or a planet ravaged by ecological disaster, the result of unchecked industrial progress. The self-destruction hypothesis posits that this might be the fate of many, if not most, advanced civilizations in the universe. It's a reminder that the greatest threat to our existence might not come from the vastness of space but from within ourselves. From the Great Filter to the zoo hypothesis, scientists have wild ideas about where aliens might be, or why they're not here. Each theory offers a unique perspective on our place in the cosmos, highlighting the vastness of the unknown and the limits of our current understanding. What's your favorite theory? Comment below and don't forget to like, subscribe, and hit the bell for more space mysteries. Next up, could we live on Mars? Stay tuned.